about examples related to predicates, examples related to quantifiers. I think we have done around 10 to 15 problems we have done. Okay, now if you want to go to inference mechanism, first what you have to go is your FOL. Okay, first order logic statements should not have any for all symbols and there exist symbols. Okay, your data should be in the form of this. Okay, are you getting me? Now I'll show you a slide. Your data should be such a way that you should have only, I think it is not, the slide is not there. Yeah, sorry, it is not there. Okay, let me start my first today's topic. Wherever you have universal or wherever you have there exist symbols, okay, you should eliminate them, like what we have done in the previous first order logic: elimination of implication, elimination of by implication, elimination of negation using De Morgan's laws, associative laws, and distributive laws. Okay, how to convert the sentences into CNF. Okay, that we have already seen it. Now today, yesterday we have stopped this discussion here. Universal elimination. For example, if my FOL sentences consisting of for all, okay, for all x, I have to eliminate the for all. Okay, then wherever I have eliminated for all symbols, then I have to replace the variables with constants. Is it okay for everyone? Here what I have done it is, here I removed for all x from the FOL statement, and I'm going to substitute x by any name, that means any variable or any constant. Is it okay? Here x is a variable. Wherever x is there, I'm replacing with a constant. Then I can directly eliminate for all symbol. Now my sentence will become likes of Shivani flowers. That means Shivani likes flowers, isn't it? The substitution should be done by a constant term. Now this is called as universal elimination. This logic I am going to use in my next examples. Is it okay? Or shall I discuss once again? Give me a minute. I don't know whether I have pressed the recording or not. Let me check it once again. Yes, I have pressed it, please. Is it okay, or shall I discuss once again about universal elimination?
It's okay, so you can move forward.
Yeah, thank you. The second one is, first one is completed. Second one is existential elimination. That means wherever you have there exists symbol, okay, that we have to eliminate it. If you want to eliminate existential variables, there is a separate theory. It is called as columnization. Now I will jump from this slide to that internal rules of columnization, and I'll come back. Okay, this I will discuss after 2 minutes. Now let me touch what is columnization for 2 minutes. Shall I go? Now existential elimination, that is nothing but if I want to eliminate there exists symbol, I have to use a methodology called as columnization. Let me discuss what is columnization. Okay, columnization is a technique, okay, which conversion of sentences of FOL into CNF requires columnization. What is CNF? Whatever the FOL sentences are there with us, okay, FOLs are nothing but there exists symbol. Okay, if your first order logic sentence consisting of there exists symbol, now we are going to use columnization to convert the FOL sentence to CNF. CNF stands for conjunction of disjunction normal forms. Okay, the process of converting FOL statement into CNF is known as columnization. Okay, columnization, what it will do is, which removes existential quantifiers. For example, if my sentence has there exists, it is going to remove this by introducing, please observe carefully, by introducing new functional symbols. Okay, here what it is going to do is, it will do two jobs. I think, are you getting me? Hello? Here you have to be very careful about columnization. Once again, columnization is used to convert first order logic sentence into CNF. Okay, if I want to this is my first order logic. Okay, are you getting me? This is my first order logic. Which is my first order logic? This is my, okay, there exists likes flowers of X. This is my first order logic. If I want to convert this first order logic into CNF formats, what I have to do is, into CNF I have to use columnization. Now If I want to remove the existential quantifiers, what I have to do, I have to introduce a new functional symbols. I have to, wherever that symbol x is there, I will try to introduce a function like greater than x or equal of x, less than or x, like that. I will try to write my own user defined function. Okay, the user defined functionality is to replace the x variable. Now, shall I show with a small example? Hello? Is it okay for everyone? What is columnization?
Yes, sir.
Now, we will go to our example, then I'll go to now. Here, what I have done, now, if columnization means there exists x here, now I wanted to remove there exists x. Now, wherever x is there, here I'm replacing with a person. Now, you can ask one question, sir, when to use columnization? Okay. Now, there are two rules for columnization I will discuss after 10 minutes. Okay. Rules for columnization, this will come here itself. Maybe it is not coming here. Please discard, sorry. It will come later, okay? It will not come right now. It will come in the next slides. Okay, rules for columnization, it will come in the next slides. Okay. Here, what we are discussing is, yes. Now, give me a minute. Yes, wherever if you are removing there exists symbol, it is called as existential elimination. Now, if I want to eliminate this there exists symbol, now wherever there is x there, I have to replace with now you can ask one question, why you are replacing with person? Okay, are you getting me? There are two kinds of there are two kinds of substitution. You can substitute with a constant. You can substitute now here, as long as person is not in the knowledge base. Here I don't know what is this x in my knowledge base. No one has specified that percentage. Now there exists x likes x flower. Now in this knowledge base we don't know what is that x. So now who likes the flowers? It can be, now I would try to use my knowledge, my personal knowledge, and I will make it as person. There are two kinds of one is I can have a person, and or I can also use some function name, some function f of some f access. I will now what this function will do is, it is a magical function. It is going to replace wherever x is there, it is going to replace with function. Now I will tell you that through two rules after 5 minutes. Okay, till that time what you remember is wherever existential elimination is there, that x or y, that variable is replaced with a knowledge which is not available in the knowledge base. Okay, as long as person is not in the knowledge base, here whatever I wanted to replace with x, here in universal elimination is nothing but simply I will replace that variable with a constant. Here I am not calling the person as constant. Okay, it is some x, some it is some kind of a magical function. Okay, that function will replace the value depending upon the knowledge base. Okay, here I need another 5 minutes time to give more about now rules I have given in the next coming slides. Okay, till that time what you remember is wherever x is there, we are replacing the constant which is not available in the knowledge base. Please remember this point. Okay, I will try to introduce them in the next coming examples. Okay, existential elimination means if I want to eliminate their exist symbol, I have to replace that variable x with a knowledge which is not available in the knowledge base. So I am replacing with, now person I cannot call it as a constant. I already used here. Okay, now you please remember that I am using a function g of x. Wherever x is there, I am going to replace with g of x. Okay, for time being. Okay, I will tell you much more rules about columnization in the next coming sessions. Now we'll see a small example about columnization. Okay, now how to convert this FOL into CNF. Now every philosopher writes at least one book. For example, if it is your sentence, now here this is nothing but FOL. First we are converting the sentence into FOL statements. Okay, first order logic. Every philosopher, so we have taken there exists, sorry, for all x. Okay, for all x, philosopher of x. Okay, and here they have specified at least one book. Okay, they have specified at least one book. So there exists philosopher, we are using a variable x, and book we are using a variable y. There exists book y, and who is going writing? Who is writing? This philosopher is writing a book. Now x is a philosopher, y is writing a book. Now x means philosopher writes a book. Now we have converted the sentence into first order logic. Any problems with this conversion of sentence to FOL? If it is okay, I will try to apply the columnization technique. Now could you please answer me?
You can proceed, sir. No
Okay.
doubts over that.
About this
Yes, sir.
statement, how to convert, yesterday we had done around 10 to 15 problems. How to convert a sentence into first order logic. Is it clear?
Yes, sir, it's clear, sir.
I am waiting for your answer. If it is okay, then I will
Yes, sir,
start.
it's clear. It's clear, sir.
Now in this example, do you have an implication? Yes, implication. Now wherever there is an implication, you should convert it into negation of P R Q. Will you agree? Now
Yes,
here
sir.
this statement, this predicate, if you call it Q. Now can I write this implication as negation of P R Q? Now is it okay? Now is it? Now I am ready to use columnization technique. Now look at here carefully, observe now. From this FOL, I have converted into, I think you can call it as a one. We have eliminated implication. After elimination, I got this FOL. Now what I'm doing is, observe carefully, columnization. That means substitution of y. Here we don't know one book. Okay, what book, that we don't know. Okay, so what we are doing is, wherever there is a y, I am substituting with a function. Okay, in previous also I told the same thing. I am, wherever there is x, I am substituting with a function. Okay, are you getting me? Please tell me whether it is okay or not. Now wherever I don't know, so we don't know that. Okay, it is out of our knowledge base. So I am replacing y with a function g of x. You can ask one question, sir, what is the functionality of g of x? G of x is a magical function. Once we know the knowledge base, the g of x will be replaced by the original one. Is it okay? Now this is our columnization. Now for all x, negative philosophy of x, or philosopher book of g of x. Wherever y is there, we are replacing with g of x. Here also we are replacing y with g of x. This process of converting a variable into a function is known as columnization. Our ultimate aim is to remove this. Observe here, I have removed there exists y. Here you don't have any there exists y. Wherever there exists y, we have removed one and we have replaced it with a function. Anything is okay? Columnization?
Yes, sir.
Yes, sir.
If you take the strict, now let me apply this. If I apply this in our, now here I have removed there exists symbol. Instead of the there exists symbol, I am replacing with P. Is it okay? P, nothing but person. Okay. Sir, if you don't want about what is a person, you can replace with G of P. Okay. I don't know what is that. Now whenever I know the knowledge base, entire knowledge base, then that knowledge base will replace with G of P with that function. Okay. Now it is about existential elimination. Third one is existential introduction. Sometimes if I have the statement like this, it is exactly opposite to this. It is exactly opposite. Now I whatever variable is there. Now Shahid likes flower. Now in the knowledge base, please, in the knowledge base, they have specified that Shahid, who is liking the flower? Shahid is liking the flower. So if I want to introduce the existential introduction, so I will try to introduce there exists x. Yes, that's it. Now wherever x is there, wherever name is there, I am replacing with there exists. This is called as existential introduction. Now if you want to write any inference mechanism or resolution mechanism, you should know about these three statements. Now I will give you 2 minutes time. Kindly note them. because we are going to apply these three mechanisms in the next examples. Is it okay? We have discussed about three things. First one is universal elimination. There we have eliminated for all x. Second one is existential elimination. There we have removed there exists x. Third one is existential introduction. Now here we are introducing, you can ask one question, sir, why to introduce? In some sort of FOL logics, I need to introduce existential introduction. I'll show you practically how to use these three in the next coming example. Once if you are very good in these three, then we will try to solve one complex example. Shall we go? Now, I'll give you 2 to 3 minutes time. Kindly complete this. The same syntaxes I'm going to use in the previous exam, next coming example. Please make it fast. Are you taking? Are you taking it?
Yes, sir.
Yes, sir.
Please make it fast. Completed? Hello?
Completed, sir.
Yes, thank you very much. Now, next 15 minutes, wherever you have any doubt, you please stop my discussion and ask n number of doubts. Now we are going to solve one complex example. Till now, whatever we have seen are just basics of first order logic. Now, whatever we have learned, we are going to apply this knowledge on that example. Are you ready now? Along with me? Yes or no?
Yes, sir.
Please take this statement. Please take this statement and take a bigger pace. Start with a new pace. Please, everybody, start with a new pace. And the problem itself will take around 2 to 3 pages minimum. Start the statement in a new page. First, let me explain it, please. First, let me explain. I have 3 statements. This is the first statement, S1. I will call it as S1. This is first statement. What is the meaning of this? If a perfect square is divisible by a prime, for example, if I take a perfect square as 36, okay, if I take a perfect square as 36, or if I take a perfect square as 25, don't take 36, please take it at 25, okay. A perfect square is divisible by prime. If it is divisible by prime, 5 is a prime or not?
Prime,
Hello?
sir. Prime, sir.
Now, can I call like this? If a perfect square is divisible by p, now can I write 5 is a prime if it is divisible by perfect square 25? Now the statement is okay till now. Then it is also divisible by the square of p. Then what is the square of p? 25. 25 by 25, it is also divisible by p. Is it okay? Now, if a perfect square is divisible by prime p, just observe carefully, prime p, then it is also divisible by its square, Is it okay, this statement? Now, second statement S2 is, observe carefully, this is not so simple. Every perfect square, for example, this is maybe here, he is saying that every perfect square, that means you can apply any perfect square. It can be 49, it can be 64, it can be 111, 144, it can be 1, and so on. Okay, every perfect square is divisible by some prime. Okay, this is second sentence. Now, what he is saying in the second sentence, every perfect square, not only 25, but also 16, 25, 36, 49, which is also divisible by some prime. He is not saying that prime. Only, for example, if I take 25, what is the prime? It is only 5. What he is saying is every perfect square is divisible by some prime. It can be any prime. Okay. Now, third statement, whatever he has given, it is statement 3 is 36 is a perfect square. Is it okay? Now, from these 3 sentences, we should prove this sentence. Does there exist a prime Q? Observe carefully. If you understand the statements, then you can easily develop the first order logic. Does there exist a prime Q such that square of Q is divides square of Q divides 36? This is my sentence. Does there exist a prime Q? Take any prime Q such that the square of that Q, okay, for example, if I take 2, for example, what is 2 square? 4. 4 divides 36. I have to prove it. Are you getting? Just for example, I have taken 2. It can be any number, okay, that will prove it. If it is the statement is okay, then we will start the process. Is it okay? Take this as first statement S1, take this as second statement S2, take this as statement S3, and this is nothing but we have to prove it. This will be prove. Please take the sentences. We will try to do step by step. Everybody started taking?
Yes, sir.
Now, can anyone tell me what would be the next step? What next? What is the next step we have to do? I need some information from you also. It should be interactive class. Clear? What is our first step? We should convert the sentences S into FOL. Everyone will agree?
Yes, sir.
Yes. Now we should convert including sentences with this provement. This also we should convert into first order logic. Shall we go?
Yes, sir.
Shall I move? Yes. Now everybody has taken the sentences. Hello?
Yes, sir.
Yes, sir.
Yes. Now, yes. Now, please be carefully convert each and every sentence into FOL. Please observe carefully. If a perfect square, he is asking about perfect square. Okay. That if a perfect square is divisible by a prime Q. Okay. Okay. If a perfect square is divisible by a prime Q, then means you will get an implication. Okay. Then it is also divisible by the square of P. Okay. Then it is also whatever the P you are taking, that is also divisible by the square of P. Now here, if a perfect square is divisible, okay, we don't know what perfect square, so you can take it as universal rule. Okay, for all X, here you can take for all Y. Are you getting me? Now what is the meaning of X? Perfect square of X. Okay, perfect square of X, and you are going to take prime of P. Instead of P, we are taking Y. Okay, that variable you can use any name. Okay, now wherever P is there, I am replacing with Y. Okay, for all X, comma, for all Y, perfect square of X. My sentence is perfect square of X divisible by prime. Okay, and I am concatenating these two. I am getting divides X by Y. Okay, for example, if I take 49, if you take it as perfect square, it is divisible by 7. Okay, are you getting me? Divides X by Y. Now what is X? Can anyone tell me what is this X? X refers to X refers to X refers to
Perfect square.
perfect square. Y refers to prime, isn't it? Now if the statement is okay, then implication is, what is the implication? Then divides of X by the square of Y, isn't it? Same thing here, whatever divisible by whatever X is there, that is divisible by the square of Y, isn't it?
Yes, sir.
Yes. Please take this statement. It is a compulsory question in the exam. In the mid 100%, I will give this kind of question. In the external exam also, definitely you may get either a short answer or an essay question. Please practice more number of questions. If you ask me, I will prefer Rich and Knight textbook. From the Google, you try to download that book, and in that you have one chapter called reasoning, knowledge representation. There you have so many examples. Maybe I studied in 17 years back. Shall I go to second statement? Hello?
Yes, sir.
Now, what is second statement? Every perfect square is divisible by some prime. Is it okay? Here, some. Okay, here, every perfect square for all x. Okay, for every perfect square, all sum over x, and some prime, there exists y. Okay, some, we don't know, at least some, all they will be existential. Okay, every, for all, there you have to use universal. Is it okay? Now, for all x refers to every perfect square, there exists y refers to some prime. Okay, perfect square of x and prime of y. Okay, perfect square of x and perfect and prime of y, which divides x by y. Clear? Third one is no need to discuss much about it. That is direct, it is a direct sentence. 36 is a perfect square. So 36 perfect square. Directly we can write it. Please take the sentences 2 and 3. Boss, you can write any number of ways. A sentence can be written into FOL 100 number of ways. I am showing only one way. If you are interested, you can write any other way also. Okay. Try to complete till now. Once if you do this problem, you can do 100 problems. Okay. Once if it is completed, you please tell me yes. Shall I go? Shall I go?
Yes, sir.
Yes. Now, what you wanted to prove? What we wanted to prove? Does there exist a prime q? Okay. Observe carefully. Does there exist a prime q? Yes. There exists a y is a prime q such that the square of q divides 36. Okay. That is there exists a prime q prime and divides this 36 with the square of y. This we have to prove it. Okay. This sentence we have converted into FOL. Please make it fast. Then we will start the solution. Till now we have represented just whatever sentences they have given in the form of FOL. Now we will start our problem. Yeah, completed?
Yes, sir.
Yes. Now, we have 3 sentences and we have 1 sentence to be proved with us. Okay. Shall I call it as knowledge base? Whatever the sentences we have in our hand, now shall I call it as knowledge base? Yes or no?
Yes, sir.
This is called, we are calling it as FOL. Okay. First order logic. Now, yeah. Now, Everyone knows these statements now. Please look at the statements one by one. Okay. Now, first I will take one statement. Okay. Now, can I infer wherever perfect square of 36 is there? Now, please observe carefully. Wherever perfect square of 36 is there, can I replace any value with a variable? Now, first I'll start with the second statement. Okay, please. Now, in the previous examples, here we discussed that how to eliminate universal elimination, then how to eliminate existential elimination. Is it okay? Now, I am going to use these steps. Here it. Now, look at here what I am doing. The first step is here I wanted to remove there exists y. Now, if I want to remove, I can use either of these. Either I can go for elimination of universal elimination, or I can go for existential elimination. It is up to us. Now, here what we have done it is from 2, first we are eliminating universal elimination. Now, whatever the universal elimination we are discussing, what we have to do, wherever there is a variable, that we have to replace with a constant. Will you agree? Yes or no? Wherever the variable x is there, can I replace with a constant x or no? The substitution should be done with a constant. Yes or no? Hello?
Yes, sir.
Now, here, could you please tell me what is a constant? Now, if I want to eliminate there exists x from this statement too, now, can I replace this x with 36 perfect square? Here also I have a perfect square. Here also I have perfect square. Can I replace that x with 36? Yes or no?
Yes, sir.
Now, I can remove there exists x. Now, here also I have to remove 36. Wherever x is there, I have to replace with 36. Yes or no? Is it clear? Now, here what we have done, from equation 2, we are going to eliminate universal elimination. Here what we have done it is, now wherever x is there from statement 2, there I am replacing with 36. Here x is there, replaced with 36, x is there, replaced. Now I don't have for all x. For all x, after removing for all x, we have replaced with 36. Yes or no till now? This statement is okay for everyone? Hello? This statement is okay till
Yes,
now?
sir.
Yes. Please take this. Step by step we will move. Here you write it as from equation 2 or from step 2. From 2. And universal elimination. We have removed for all x, where we have replaced x with 36. And after every statement, you please write it in your English words for the exam person. Okay. Once if it is okay, then I will go for existential elimination. I wanted to remove there exists y. Now, once if it is okay, then I wanted to ask one question. Shall I go? Hello?
Yes, sir.
Yes. Now, shall I go?
Yes, sir.
Yes. Now, within this problem statement, do I have any knowledge of what prime number I am dealing with? Please, anyone answer for my question? Do I have a knowledge of what prime number I am asking? What is prime P? Do you have any knowledge about prime P in this knowledge base, KB? Do you have any knowledge base? What prime P we are taking in this problem? Yes or
No,
no?
sir.
No. So, I am replacing with P. That's it. If I want to eliminate universal elimination, sorry, existential elimination, now I will remove there exists y, and wherever y is there, I am replacing with P. Observe carefully, the same sentence here also, and here also I am replacing with P. That's it. Now, my statement 2 is now free of universal elimination and existential elimination. Kindly take this step 5. Make it fast. And do you have any explanation needed for this? Now here I have removed their exist symbol, and wherever if I have y, that there I'm going to replace with P. You can also replace with a function name, some prime P like this. It is up to you. Now my equation says that after eliminating their exists y, now wherever y is there in my fourth equation, now I am going to replace with P. Is it okay till now? Hello? Is it completed? Hello?
Completed.
Yes. Now, can I apply the same process, same universal elimination, and there exists elimination on equation number 1? Can I do the same process? Now, here I am doing. Observe carefully. Let me erase it. I will do the same process. Whatever I have done for statement 2, I will do it. Now, after removing there exists x, what I have to do? Wherever x is there, shall I replace with 36? Yes or no? Here I will replace x with 36. Here I will replace x with 36. Yes or no? Here also,
Yes, sir.
yes, here also I will replace x with 36. Now, I have removed universal elimination. Now, can I remove y also? Here, this is also for all y. Can I remove y also? Wherever y is there, I have to replace with p. Wherever y is there, I am replacing with p. Wherever y is there, I am replacing with p. Now, isn't it? Now, isn't it completed? Yes or no?
Yes, sir.
Yes. Please take this step. Applying the same knowledge on equation 1, now I am going to remove universal of x and universal of y. I know that universal of x can be replaced with a constant 36 and universal of y can replace with any variable. Okay. Here I don't know what is prime p, so I am replacing with p. Once it is completed, you please match, please observe carefully. You please match statement 1 and statement 5. Can I explain?
Yes, sir.
Now, observe carefully. Now, first let me go to statement 5. What is statement 5? Perfect square of 36 and prime of p and divides of p. Now, observe carefully. What I am doing is perfect square of 36 and prime of p and divides of p. Can I replace this sentence with this? Yes or no? This is statement 5. Is it looking like statement 5? This one. Perfect square of 36. Observe carefully. Perfect square of 36 and prime of p and divides of 36p. Is it looking like? Now, wherever this statement is there, can I replace with divides of 36 and the square of p? I need an answer from you, man. నేను ఎంత దిగజారి చెప్తుంటే మీరు ఆన్సర్ చెప్పకపోతే నేనేం చేయాలి చెప్పండి?
Yes, sir, we can replace.
That is what I am asking from you. నా స్థాయి దిగజార్చుకుని అడుగుతున్నాను, అది నేను రిక్వెస్ట్ చేయాల్సిన అవసరం లేదు నాకు. కెన్ ఐ రీప్లేస్ దిస్ 5 with 1 అని చెప్తుంటే ఎవరు ఆన్సర్ చేయరేంటి? Is it looking like whatever the equation 5 we got, is it looking like this one, left side? Wherever the implication is there, if it is true, that it will become true. So I will consider, instead of 5, I will replace with the divides of 36 square of p. Yes, I know. So this is my outcome. From 1 and 5, this is my outcome. Yes or no?
Yes, sir.
Yes. Take this sentence. Take this sentence till now. Completed till now?
Completed.
Yes. Now observe carefully. Now observe statement 5 and 6. Now divides of 36. Now can I replace this p with a function square of p? Hello.
Yes, sir, we can.
Now this one. Now prime of p divides 36 square of p. From 5 and 6, we can write that prime of p and divides 36 square of p. Okay, please. From 1 and 5, we got this statement. From 5 and 6, we got this statement. Sorry, we got this statement from previously. Okay, we have done here now. Wherever we have this statement that I am going to replace with that divides 36 square of p. Is it okay that we already got it? Not from this statement, we have not got it only from 5. It is from 1 and 5. Now, from 5 and 6. Now, can I get prime of p divides 36 square of p? I'm sorry, give me a minute, a small misunderstanding. Now here, how we got this statement? Now, wherever prime of square 36 and prime of p divide of 36, this, let me erase it. Is it looking like this left side statement? Now, I'm replacing wherever I find this statement. These two are not there. Okay, where I can replace with the divides of x with divides x comma square of y. Now, I got the same thing. Clear?
Yes,
Hello?
sir.
Now,
Yes, sir.
after this, now write this next note. From statements 5 and 6. From statements 5 and 6, we can infer that. I can infer that wherever p is there, can I replace with a square of p? Hello? Can I replace?
Yes, sir, we can replace.
Yes. Now, if it is okay, please wait a minute. Please wait a minute. Now, here we have discussed one more new rule. What is existential introduction? If I don't have any existential introduction, now here what I have done, instead of this, I wanted to, if I know the variable, if I know this constant directly, I can, by introducing existential introduction, I can use there exists symbol. Now I can instead of Shahid, I can replace with x. Will you agree this statement? This is previously we discussed it now.
Yes, sir, we can.
Now from the problem, what they asked, there exists y, prime of y divides of 36 comma square of y. Is it our problem? This we have to prove. Okay, yes or no?
Yes, sir.
Now I already got up to here. Observe carefully. I already got up to here. Prime of p divides of 36 square of p. Now here what I am introducing? Introduce existential introduction. So now here, before that, I am adding there exists y. Wherever p is there, I am replacing back with y. Wherever p is there, I am replacing back with y. Now, did I get the same? Whatever I have to prove, did I get the same thing from this or not? Does there exist a prime q such that square of q divides 36? Do you got the same thing here? Finally, did you prove that using FOL?
Yes, sir.
Yes, that's it. Please take it. It is a simple example, though it is complex. If you practice once or twice, it will be very simple to you. Okay. Now, once if you know this kind of examples of conversion from universal to normal, and there exist universal and existential quantifiers to normally, and how to introduce existential quantifier, and how to convert implications to normal. These, if you do and conversion of sentences to FOL, then we will start a concept called as resolution in first order logic. If it is okay, then I'll go to next topic. Now this is the problem where we have to prove. We have already proved. The continuation, the problem is not yet completed. I will continue in the next coming slides also. As far as problem is concerned, here completed. Now I will introduce still more sentences in the next coming slides about this problem. Completed? Hello?
Yes, sir.
Now, shall I move to next one?
Yes, sir.
Now, inferencing. Perfect square of 36. Prime of P divides 36P. Now, there exists X, there exists Y. That we have already, this concept inferencing, I will discuss the next coming slides. Okay, not now. I will try to inferencing. I have not start now. Inferencing I will start in the tomorrow's class. I'll continue the same topic. Please be itself and let me open a new PPT. Okay. I need to discuss some other new syntaxes. Please give me a minute. This example, please give me a minute, please. Predicate logic example. Yes, let me share the screen for 1 minute. Let me share the screen. Could you please observe this PDF? Is it okay? The screen is okay for everyone? Is it visible?
Yes, sir. Yes, sir. It's
Give me a minute. Let me go to the example. Yes, knowledge representation, inferencing. Why this? Where is that PPT? Sorry. Just give me a minute, please. Please. Sort by date modified. Reasoning in effort. Yes, very good. Let me share the screen. Yeah, is it okay? Now, I wanted to introduce a new principle, that is Hahn clauses, okay, are also called as Hahn sentences, okay. Till now we have completed this problem. The next one is Hahn sentences, okay. If you want to convert FOL into CNF, we need the help of Hahn sentences. Now let me discuss about 2 minutes about Hahn sentences, okay. What is called as atomic sentences? Atomic sentences are nothing but any small sentence can be called as atomic sentence. Now, let me discuss is what is the meaning of sentence. I have to give it for 1 minute. Now, yes, now give me a minute. Now, what is called as Hahn sentences, please? The implication of, please observe carefully, the implication stands for arrow symbol, okay. Now observe carefully, please come along with the implication within a conjunction of atomic sentences. What is the meaning of conjunction of atomic sentences? Can I call it as and symbol? This is one atomic sentence. For example, if you take the problem, this problem itself, this is one atomic sentence. There exists y prime of y is one atomic sentence. Are you getting me? Please. This is one atomic sentence. This is one atomic sentence, and this is another atomic sentence. These two atomic sentences are joined with conjunction. Will you agree? Hello?
Yes, sir.
Now, the same example I'm discussing. And same thing I'm representing in the form of sentences. Implication with, observe carefully, implication with conjunction of atomic sentences. Here, this is an implication with the conjunction of atomic sentences. This is one atomic sentence, this is one other, and symbol, this is another atomic sentence, and symbol, this is another atomic sentence. Implication with conjunction of atomic sentences on the left side, this is on the left side, and a single atomic sentence at right side. If you have any sentence in this format, we can call that sentence as Horn sentence. And remember carefully, the Horn sentences cannot have existential quantifier. Please, can anyone echo with me? What are Horn sentences? Okay, Horn sentences will be the form of, left side is, you can have universal quantifier, but you cannot have existential quantifier. Okay, left side you should have any number of atomic sentences, but all the atomic sentences has to be with conjunction format. Please, this is one atomic sentence, this is another atomic sentence, and this is another atomic sentence. Here these three atomic sentences are joined with conjunction with an implication at left side. Right side is, you should have only one single atom or atomic center at side. Now this kind of sentences can be called as Horn sentences. Is it okay? If it is okay, I will go to next one. Please take this line, please. Only these two lines. Take one small subheading, Horn sentences, and please take this, because Horn sentences, I need some examples. I'm going to use this concept in the next coming examples. Implication with a conjunction of atomic sentences on the left side and a single atom on right side. If any sentences are in this form are called as Horn sentences. Note point is, they should not have existential quantifier. Okay, but they can have universal quantifier. Is it okay for everyone? Hello?
Yes, sir.
Now,
Yes, sir.
the thumb rule is implication. This is implication, and you are having conjunctions in between atomic sentences at left side, and right side is, you should have only one sentence. And basic rule is, Horn sentences cannot have existential quantifier, but they can have for all symbol. Okay, now if it is okay, I will move to conversion to Horn sentences. I told you, columnization I will tell you with two rules. Next to 3 minutes discussion is very, very important. Kindly bear with me and understand it carefully, please. I told you columnization in the previous slide. I told you that there are two rules for columnization. Existential quantifiers can be removed. What is columnization? Existential quantifiers are nothing but there exists symbol can be removed using existential elimination, called as columnization. Please observe carefully, called as columnization. Okay. Now, two rules to be satisfied. If existential quantifiers is outside of any universal quantifiers, that means in previous example, we don't know what is prime P. Okay, we don't know what is that. Then you have to introduce a column constant. You are introducing a column constant. Okay, wherever there is a y, you are replacing with P. Did we done the same thing? Yes or no? If I have a sentence like this, there exists y prime of y, we have replaced y with P. Yes or no? Where P is a column constant. Hello? We have already used this knowledge in the previous problem. But in the examination, if they ask about what is columnization, you should write about these two rules. Okay? If the knowledge is outside of the knowledge base, you have to use columnization. Okay? Then second point is, otherwise, the column function is introduced. Column function means, for example, if you look at here, there exists x, sorry, for all x, there exists y. Here I prime of y and divides of xy. We have the sentence. Here we are replacing, observe carefully, we are replacing y with PD of x. Here we are replacing y with PD of x. Here PD of x is a Skolem function. Now observe carefully in these two sentences. If the knowledge is outside of the universal quantifier, you can use two things. One is either by using a Skolem constant or by using a Skolem function. Hello? The process of introducing
Yes, sir.
either a constant or a function, okay, is called as Columnization. I need everyone, please take this, and I'm going to introduce the much more concepts about columnization in the next example. Clear? Now, with this, today we will close the discussion, and if anyone has doubts, we will try to answer those doubts. Hello, shall I? Please take this, and I will try to close this. In tomorrow's class, we'll try to use resolution in first order logic. In the previous class, we used resolution in predicate logic. Now, we will try to discuss resolution in first order logic. Once it is done, we will go for a new concept called as unification. Maybe unification we will discuss in the next unit, next week. Next week, we will try to close second unit. And we have new concepts called forward chaining and backward chaining. We'll complete by next week. Completed? Everyone? Hello? Is it
Yes,
complete?
sir. Yes, sir. Completed.
Thank you. Thank you very much. Let me take the screenshots. Yes, I got the screenshot. Any doubts? If you have any doubts, I'll wait for another minutes. Otherwise, I will leave. Any doubts in today's class?
Sir, so basically, these sentences are the rules, no, sir? Those two sentences.
No. Sentences are not rules. Sentences are the knowledge base or domain knowledge. Sentences can be called as domain knowledge.
Okay, sir.
Domain knowledge of the problem. Okay.
Okay, sir.
Can I close or any questions? Any other questions?
No questions.
Okay. Thank you very much.